Reduction formulas, this is the lesson 10, and I'm going to explain this lesson, reduction formulas. And in the reduction formulas part, you have to we are going to try to relate the angles which are located in second, third, and fourth quadrant to first quadrant. So angle is written second, third, or fourth. Let's say the angle is in the fourth quadrant, which is 330 degree. 330 degree in the fourth quadrant, and I'm going to relate this 330 degree with 30 degree. This relation somehow it's going to be, and I'm going to say magic occurs, and this magic is called reduction formulas. Reduction formulas. And this, when we are looking for cosine 330, let's say cosine 330 by magic of reduction formulas, it's going to be equal to cosine 30, and it's going to be equal to root 3 over 2. I'm going to explain how to that one. So if you want to understand reduction formulas, you need to know this page very well. So what is written on this page? This two information, the figures, you have already know them. The quadrants, this is the first quadrant, this is the second quadrant, this is the third quadrant, you know, and the fourth quadrant, you know the quadrants, and these are also showed the quadrants. In the first quadrant, sine is cosine, tangent and cotangent is positive, or in the third quadrant, sine and cosine is negative, this one and this one is negative. So tangent and cotangent, they are both positive, negative over negative, negative over negative, it's going to be. So they are both negative, it's going to be. So when the angle is given like 300 degree here, we are going to relate this angle like in the first quadrant and 30 degree. And we are going to use this text for the formula. Formula is pi over 2 and 3 pi over 2. If it is 3 pi over 2 and 3 pi over 2, which is 90 degree, and 180 degree, we are going to change the function, we are going to change the function. Sine to cosine, cosine to sine, tangent to cotangent, cotangent to tangent. If we have pi and 2 pi, we are not going to change the function in the formula. If there is pi and 2 pi, we are not going to change the formula. Here, with the example, I'm going to explain, I think, better, because without example, it's not easy to understand this one. Now, these are the formulas that is given to us. Here, we have pi over 2, 3 pi over 2, 3 pi over 2. So, in these formulas, we have pi over 2 and 3 pi over 2. In these formulas, we have pi and 2 pi. Actually, minus x means 2 pi minus x. You need to know also that one. Okay, pi over 2 minus x. So they are going to be equal to, here, they are all going to be equal to, first thing, this expression, it's going to be equal to cosine x first thing. I need to tell that one, cosine x. Why? Because in the formula there is a pi over 2, so I'm going to change to cosine function. This is going to be cosine x also. This is going to be cosine x. This is going to be cosine x. Because all these are pi over 2 and with 3 pi over 2. So we are going to change the function. All these are with pi and 2 pi. That's why we are not going to change the function. So they are going to be equal to sine x and sine x and sine x. Here I have to be careful about the signs. Now I gave space between them because I want to show the sign. This angle is in the first quadrant. In the first quadrant, sine is, if you remember, sine is plus. So this sign it's going to be plus. Sine pi over 2 plus x. In this sine pi over 2 plus x, it's going to be second quadrant. In the second quadrant, sine is plus again. So this is plus. In the third quadrant, sine is negative. In the third quadrant, sine is negative. If you remember from this table. Here in the third quadrant, sine is negative. So it's going to be equal to minus cosine x. Here in the fourth quadrant, 3 over pi over 2 plus x, which is 270 plus x, it's going to be minus again. Yes, sine pi minus x. This is second quadrant, pi minus pi. I couldn't write, sorry. Here this is the pi over 2. And pi minus x, when you say, you're coming to this one, so it's in the second quadrant. Second quadrant, pi minus x. And in the second quadrant, sign is plus. Pi plus x, it's going to be minus because it is in the third quadrant. 2 pi minus x or minus x, it's going to be in the fourth quadrant, and in the fourth quadrant, sign is negative. It's going to be again. Okay, so these are the results of the trigonometric formulas. Okay, now let's give some numerical examples. Sine 120. Sine 120 is equal to what? I'm going to find now. These are sine 120. Sine 120 can be written as sine. I'm going to relate this one with pi over 2 or pi or 3 pi over 2 or 2 pi, which is these numbers are 90 degree, 180 degree, and 270 degree, and 360 degree. They are going to be. Now I'm going to relate 120. I'm going to relate 120, sine 120. I'm going to relate with 180. By using 180, how can I write 120? 180 minus 60 gives us 120. So sine, it's going to be sine 60. This is in the second quadrant. In the second quadrant, sine is positive. The sine value is going to be, that's why the sine of the sine is going to be positive. And sine 60, we know that it's equal to root 3 over 2. How we know that's root 3 over 2? If you remember, this is the 0 and this is the 90 degree, and we made the fingers like this, and this is 30, 45 and 60 degree, and at the same time these are 0, 1, 2 and 3 and 4. So sine 60 is here this one, and it's equal to root 3 over 2 is going to be. Sine 120 also can be written as 90 plus 30. Sine 90 plus 30 is equal to sine 120, and this is, you know, pi over 2. When we have pi over 2, 90 and 270, we are going to change the function. So this is going to be equal to cosine 30, and cosine 30, we know that from the table it's going to be equal to root 3 over 2. In the second quadrant, cosine is positive, that's why this sign is going to be plus. Pardon, in the second quadrant, sine is positive, that's why this sign is plus, and the answer is going to be equal to root 3 over 2. Here we are going to solve for the cosine 240 degree. Cosine 240 degree for the b. Here, this is the first way, by the way. This is the second way. So you can write the cosine 240 in two different ways. Cosine 240 can be written, cosine 240 degree can be written as cosine 180 plus 60 is, it can be, or cosine 240 is going to be equal to cosine 240, sorry for writing mistake. Cosine 240 can be written as cosine 270 minus 30. So when we have 180, we are not changing the function, cosine is going to be. When we have the 270, we are changing the function, so it's going to be sine. Cosine 60, sine 30, it's going to be. Cosine 240, it is in the third quadrant. In the third quadrant, cosine 240 is negative, so the answers both, they are going to be negative. And cosine 60 is equal to cosine 60 or sine 130. They are equal to each other, so it's going to be equal to minus 1 over 2, and you know that it's equal to minus 1 over 2, root 1 over 2 is going to be. Okay, For the cosine, if we do this table, for the cosine, if we do the same table, if you remember, we were doing like this. This is the 0 degree. This is the 0 degree and this is the 90 degree. The angles, it's not going to change. Here, this is going to be 30, 45 and 60 degree. Here for the cosine, while we are counting for the cosine, we were counting from the 0, 1, 2, 3 and 4. So cosine 60 is here, so it's going to be 1 over 2.